Hello everyone. In this video, we have discussed about the JEE Main PYQs of motion in a straight line chapter. So in 2026, around 10 questions from motion in a straight line here we have collected, and you can see the PDF of the question that will be available to you in the description box. You can also download the solution PDF from the description box. So let's begin. So the first question here we have to find out the acceleration, right? They have given the velocity expression as minus x I cap plus 2y j cap minus z k cap. And from there you have to find out the acceleration at a particular point 1, comma 2, comma 4. So here you are seeing that velocity is continuously varying in all the three directions, as minus x I cap is the component along x direction, 2y, and similarly minus z along the z direction. So here what we can do is we have to find out acceleration along each direction, like ax I have to find out, ay I have to find out, az I have to find out. That is the key idea here. Acceleration along each direction I'll find out. Then I can substitute the value like 1, comma 2, comma 4 at respective point. Then I'll get the acceleration. So let's see here. First find out ax. So ax here we have written dvx by dt. That's quite simple. Here all of you know that differentiation of velocity is acceleration. Then here just we have multiplied ds and divided by ds, rearrange the formula, and we got vx as dvx upon dx. So vx, like velocity along x direction, this component we have minus x. So in this vx we can substitute minus x, and differentiation of minus x we can do that, we will get minus 1. And substituting the value here we are getting as x. This is our acceleration along x direction. So we can write down x I cap. Same process we can apply to find out acceleration along y and acceleration along z. So here you see, similarly I am getting acceleration along y as 4y j cap I can write down, and similarly acceleration along z I can write down z k cap. So finally we are getting the expression for acceleration as x I cap 4y j cap plus z k cap. Now we can just need to substitute the value of 1, comma 2, comma 4. So here by substituting the values, we will get it as 1 I cap, here 4 into 2, 8 j cap plus 4 k cap. Now just find out the magnitude, root over you can take of 1 square plus 8 square plus 4 square. So we are getting the acceleration as 9 second square. Now let's move on to the next question. It's a very good question. Now in this question here they have given that two cars are there which are moving in the same direction along the same straight line with a speed of 100 km per hour and 80 km per hour respectively, such that car A is moving ahead of car B. Okay, let's draw down the situation. Here let it be car A. This red color car is car A, and this blue color car is car B. Now the speeds also will mention here 100 km per hour, and the next car speed is 80. Both are moving in the same direction. Now a person in the car B throws a stone with a velocity of v so that it hits the car A with a speed of 5 meter per second. Okay, so here suppose I am throwing, here it is throwing, the person is throwing with a speed of v kilometer per hour. Then this is going to hit car A. So what will be the speed of the stone with respect to ground? The speed of the stone with respect to ground, if you see, already the car B has a speed of 80 plus extra speed v is provided to the stone. So total it will have a speed of 80 plus v. Okay, this is going to be the speed of the stone with respect to ground. Similarly, now the stone once is going to hit to this car, they have mentioned that the relative velocity is 5 meter per second. Here we need to be careful. We have to convert this into kilometer per hour. Like here you can see the speed of the stone with respect to car A I am finding. So it is 5 meter per second they have given. So we just converted into kilometer per hour. So it is coming 18 kilometer per hour. This is the speed of the stone with respect to car A. Now we can write down like relative velocity of stone with respect to car A. We can write it as relative velocity of stone with respect to ground and velocity of car A with respect to ground. So this particular velocity here they have given 18 in the question. So we have substituted here 18, and velocity of stone with respect to ground is how much? 80 plus v, and velocity of A with respect to ground, that is the simple velocity of car A is given 100. So all the values we have substituted, just rearrange that and we'll get the velocity as 38 km per hour. Option C is correct here. So now let's move on to the next question. So you can see that from 18-meter height above the ground, a ball is dropped from rest. Okay, let's consider here a tower which is suppose 18 meter. Let's write down this is 18-meter height from the ground. So we can mark this also. 18-meter is the total height I'm marking. Now a ball is dropped from rest. So you can take a ball will be dropped from rest. The height above the ground at which the magnitude of velocity is equal to the magnitude of acceleration. This is the condition of the question. Magnitude of velocity must be equal to magnitude of acceleration. So acceleration all the time here will be equal to g because it is under free fall. That is 10 meter per second square we can take. So here they are saying that velocity also should be 10 meter per second square. When this velocity become 10 meter per second square, at that particular time we have to find out what is the height of that particular point. So here we can take the initial velocity is 0 since the ball is dropped from here. So we can take initial velocity as 0. So acceleration is 10 here, and as per the condition, here we have to take that velocity magnitude is equals to acceleration magnitude. So velocity will be here 10. Now simply we can apply the equation of motion, third equation of motion, v square equals to u square plus 2gs. So 10 square equals to, here u is 0, you can know that g value also 10 we have substituted, and we are getting the value of s as 5 meter. So that means when the ball has moved by a distance of, here it is moved by a distance of 5 meter, then here at this point the velocity of ball becomes 10 meter per second. Now in the question they are asking the height from the ground. Total height is 18, so remaining height will be how much? 13. So 13 will be the answer because 18 minus 5 already traveled from the ground, it will be 13. Okay, now let's move on to the next question here. Graph question. Very simple question. Here they have asked to find out the total distance and average velocity. So velocity time graph, distance they asked. Simply add all the area. This is area 1, and similarly suppose this downside area, negative area is 2, area 2. So if you do area 1 plus area 2, you are going to get distance. Area 1 minus area 2, we will get displacement. From displacement you can find out average velocity. Average velocity will be what? Displacement upon time. This will be your average velocity. So for finding distance we can simply add both the areas. So let's see. Here total distance we have calculated, area 1 plus area 2, substituting the values, we are getting 50 plus 50 as 100 meter is the distance here. Now similarly to find out the average velocity we need to find out displacement. So 50 minus 50 we have to do positive area, negative area. So both area we have to subtract. While finding displacement, negative areas are subtracted. So we are getting 0 here as the displacement, and average velocity if you check. So 0 by 40 because they have given the time as 40 seconds. So we are getting it as 0 meter per second. So we are getting the option as C, 100 meter and 0 as the average velocity. So next question. Here they have given that a gas balloon is going up with a constant velocity of 10 meter per second. Okay, let's make a gas balloon, and here it is going up with a velocity of 10 meter per second. Okay, then when the balloon reached a height of 75 meter, okay, let's take this height, it reached a height of 75 meter. Then what happened? A stone is dropped from it and the balloon keeps moving up. So after the stone is dropped, the balloon is now still moving up with the same speed, continuing to move with 10 meter per second. Now think about the stone which is dropped from here. So how the stone will move? Will it move immediately downward? Will it move like this? Will it move downward? No. It won't move directly downward. Initial velocity will not be 0. Here how the stone will move? Stone also will move up. Then after that it will move down. It will go to certain height. It will have an initial velocity in upward direction, then it will move downward and reach the bottom. So if you see the displacement of the stone, how much displacement you will get? Minus 75 meter will be the displacement. This is the initial position. This is your final position. The displacement will be minus 75. So here g value what we are going to take? Minus also minus 10 we are going to take. So if you see the initial velocity, we will take initial velocity for the stone as 10 meter per second. So we can apply the formula of s equals to ut plus half at square. S is minus 75 here. Substituting the respective values of 10 into t, half into minus 10t square, we are getting the time as solving this quadratic equation. We got the time as 5 seconds. Within this 5 seconds, the balloon would have still continued to move up, right? So how much distance the balloon would have continued to move up? Simply, we can say that the distance d equals to 5 is the time and speed of the balloon was 10. So it would have still moved by a distance of 50 meter. So total height, if you see, total height will be how much? Initially, the balloon has moved by 75 meter. From there, the stone was dropped, and now an extra distance of 50. So total 125 meter is the height traveled by the balloon So now this is how we can solve this question easily. Next question we'll see here, question number 6. So question number 6 here they have given that two masses are there, 3.4 kg and 2.5 kg are accelerated initially with a speed of 5 meter per second and 12 meter per second respectively. The distance traversed by them in the fifth second is 104 meter and 129 meter respectively. Here they are saying about the distance traveled in nth second, nth particular second. So what formula we are going to use here? We are going to use S nth formula, u plus a by 2 into 2n minus 1. This formula is going to be useful here. We have to find out the ratio of the momenta after 10 seconds. So they have also mentioned that ratio as x by 8. So let's first find out, then we will set according to x by 8 form, then we can see how much the value of x is coming. So for the first mass, if you see m1 mass is having a mass of 3.4 kg and speed initial as 5 meter per second. I'll apply the formula of S nth formula. It has given they have traveled a distance of 104 meter. So I have applied 104 meter into 5 plus a1 by 2 into 2 into 5 minus 1. So I'm getting the acceleration was as 22 meter per second square. Similarly for mass 2, we can substitute the value of 129 and the time value after 5 seconds. So 2 into 5 minus 1 respectively. Solving this, I'm getting the acceleration as 26 meter per second square. So we have to find out the momentum ratio. So we need the velocities, right? After 10 seconds, what will be their velocity? We know initial velocity, we know acceleration. Simply we can apply v equals to u plus at formula here. So we are getting the velocities as 225 and 272 meter per second after 10 seconds respectively for v1 and for v2. Now if you want to find out momentum formula we know mass into velocity. So p1 by p2 you can write down m1 v1 by m2 v2. So you are getting a 768 by 680. So here I had solved already. 9 by 8 we are getting. So x by 8 form means x value is we are getting as 9. Okay, so it's simply a calculation based question. Okay, so next question here you see they have given that a particle starts moving from time t equals to 0 and its coordinate is given by x of t as 4t cube minus 3t. So the particle returns to its original position in 0.866 units later. Okay, so let's first check whether the first statement is correct or not. We have to find out at what time the particle is at its origin. So let's first find out, like at time t equals to 0, if you see, let's put the value of time t equal to 0 and see whether where it is at time t equals to 0. If we substitute, I am getting the position as 0. Now similarly, if I'll take x equals to 0, then if I find out the time here, then definitely one time I will get 0. Okay, because here already we got by putting time t equals to 0, x as 0. It is starting from origin. So if you see that if you want to find out the another time where x is again 0, then I took here x value is 0 and I calculated the time here. So time, if you calculate, we are getting the two values of time. One is 0 and one is root 3 by 4. So one is 0 is validate because here already we got the time at time t equal to 0, it is at origin. Similarly, one more time here we got, that is root 3 by 4. So that is 0.866. So here the first statement is correct. Let's move on to next statement. They have given that the particle is 1 unit away from the origin at its turning point. So turning point means what will happen? Velocity becomes 0 at the turning point. So velocity expression here, if you see, just you can differentiate the displacement equation and you are getting the velocity equation as 12t square minus 3. So velocity is 0 at turning point. So I am getting time as 0.5. So again I have to put this 0.5 time in the displacement equation. Then I am getting this as minus 1. Displacement at minus 0.5 or the position at minus 0.5 I am getting as minus 1. So here the magnitude they have given, the particle is 1 unit away. So this is also correct. So the particle is 1 unit away from the origin. Second statement is also correct. Then acceleration of particle is non-negative. So this one we need to check that acceleration of particle is negative or non-negative, again by differentiating velocity. So here you can see, if I differentiated velocity, I got acceleration as 24 into t. Now if I substitute any value of time over here, acceleration I will get always positive. So this statement is also correct. Acceleration of the particle is non-negative. Now the fourth option, they are saying that the particle is 0.5 units away from the origin at the turning point. So this is incorrect because already we know the particle is at minus 1, that is 1 unit away from the origin at the turning point. And lastly, they have given the particle never turns back as the acceleration is non-negative. So here this is incorrect. Acceleration is non-negative. Acceleration need not to be negative for the turning point. Here we already got the velocity is 0, so that we got in a real time. So it has a turning point. So that's why here D is also not correct. So only A, B, C are correct. So A, B, C means option B is coming correct for us. A, B, C statements are correct. Okay, next question. So here they have given that water drops fall from a tap on the floor 5 meter below. At regular interval of time, the first drop strikes the floor when the sixth drop begins to fall. Okay, so if you analyze the situation here, here is the tap and here's the first drop, then second drop comes, first drop is going down, third drop is coming out and first drop is going down like this. If we continue, so here you can see the first drop is now strike the ground and here sixth number drop is coming out. This is the sixth drop. When it comes out at the same instant, first drop is striking the ground. So we have to say that like where the fourth drop will be from the ground at this instant. So this is the fourth number drop. So very carefully you see in each drop, between each drop there is regular time interval. So when the first drop is going to strike the ground, how many time instances would have passed? So between first to second drop, one time instance t, second to third drop, again one more time instance t. Similarly, this is also one more time instance, one more time instant, and this is between fifth and sixth drop, the time instance. So how many time instances have passed when the first drop is striking the ground? You can see 1, 2, 3, 4, 5. 5 time instances has passed, means first drop has consumed 5 time intervals, to like equal time intervals are there, like that 5 time intervals it took to strike the ground. So for the first drop, if you write down the equation, initial velocity of first drop will be 0. So distance traveled by first drop will be how much? 5 meter. So we can write down the equation for the first drop. So this is the first drop, as first will be how much here? 5 meter equals to ut plus half at square. So u is 0 and time taken by the first drop is 5t plus half into g into 5t square. Similarly, for the fourth drop, if you write down the equation, fourth drop we can write down as ut plus half at square. But see, fourth drop will consume how much time? Here one time between 4 to 5 and 5 to 6 one more time. So it will take 2t time. So same way we can write down 0 into 2t plus half into g into 2t square. First drop has traveled 5 meter and fourth drop has traveled S4 equals to, here these two terms are 0, so half into g into 5t square, half g into 2t square. So half g will get cancelled and t square also get cancelled. 25 by 5 square 25 by 4 we are getting, and rearranging that we got S4 as 0.8 meter. So distance traveled by fourth drop from the top is 0.8 meter. Then from the ground how much distance it will travel? So 5 minus 0.8 we need to do, because we need to say about this height. This height will be 5 minus 0.8, so 4.2 meter will be the answer to this given question. Okay, then next move on to the next question. Here is the question is, paratrooper jumps from an aeroplane and opens up the parachute after 2 seconds of free fall and starts decelerating with 3 meter per second square. Okay, still now analyze the question here. So suppose if you take, like this is the aeroplane and let us take this as the point A. From here that paratrooper jumps and at point B, suppose the paratrooper opens the parachute here. So during this time from A to B, it would be under free fall. So it would be under free fall means acceleration experienced must be g in this zone. Now what happened next? At 10 meter height from the ground, once he opened the parachute like this, it is going further moving downwards. Now the retardation is there at a retardation of 3 meter per second square. So here it is minus 3 meter per second square we can take. So once he reaches to another point, this point is C, where what is they have mentioned about the C point, that it is 10 meter height from the ground. So like this I will take as the ground, suppose. So this height is 10 meter. They have mentioned from the ground it is 10 meter height. So you can take this ground as D point. Okay. So this is 10 meter height. So what we have to say, the initial height of the aeroplane, means all this height just we have to find and add, like A to B what is the height, B to C what is the height, C to D already they have given 10. So from A to B, if you find here first, A to B path you see, it is under free fall. So we applied V equals to U plus AT and easily we can get the velocity at point B. Once the person reaches at point B, here it will have a velocity of 20 meter per second. And what is the distance traveled? S equals to ut plus half at square we can apply. So distance traveled here is coming as 20 meter. Similarly, from B to C, if you check B to C path, we can apply the V square minus C square equal to 2 into A into S. Here you see that here initial velocity will be the final velocity of the first case, that is A to B case. So while reaching B, what was the velocity here? At this point, the person has a velocity of 20 meter per second, which will act like the initial velocity for the second case from B to C path. At the end of C, the person is having a velocity of 5 meter per second. So here we applied 5 square minus 20 square equals to 2 into retardation is here minus 3. So on solving this, we are getting the distance from B to C is 62.5 meter. Now C to D, they have already given 10 meter. Now we have to find out the total height. Just add all the height here. So 20 plus 62.5 plus 10, 92.5 meter will be the answer to the given question. So very simple question. Just you have to read the question carefully, draw the perfect diagram, and analyze properly, substitute the values, then you'll get out the answer. Okay, so see, this is the last question, 10th question. So they have given a velocity distance graph, and we have to find out the respective acceleration distance graph. So you can see from this given graph, it has a negative slope, right? Here it's obtuse angle. So theta here is going to be greater than pi by 2, 90 degree. So tan 90 plus 90 more than 90, it is negative. So slope is negative. And it's a straight line. In the y-axis here, we are having velocity. On the x-axis, distance is there. So if you represent this in the form of a straight line, we are getting in place of y equal to mx plus c, in place of this m, that is the slope, I have written as minus m because of negative slope, and remaining y-intercept is positive, so plus c I have written. Now we all know that acceleration is given as v into dv upon dx. So already we have know the value of v. So if you substitute the value of v as minus mx plus c, we are getting it as minus mx plus c into dv upon dx. And further, dv upon dx is what? If you see here, dv upon dx is the slope. So in place of dv upon dx, I can write down minus m into minus m, that is the slope. So dv upon dx, we will now substitute here as minus m. On substituting that, a equals to, we are getting minus mx plus c into minus m. So if you multiply minus m by opening the bracket here, we are getting acceleration as m square x minus m into c. So look here very carefully. Again, it is represented in a straight line equation, like y, this is y equals to, this is our m into x plus c format. This is your y-intercept. Here we have a negative y-intercept. You can see we have a negative y-intercept. Similarly, here we have a positive slope and a straight line equation. We have to find out from the given graph positive slope and negative y-intercept. This one is a negative y-intercept with a positive slope. Here this graph is suitably matching with the conditions. So here option B will be correct. So like this, here we have solved all the 10 PYQ question. Further, other chapters also serially we will put all the PYQ question. Next, motion in a plane, laws of motion from class 12th, also electric charges, field, potential, serially all the chapters PYQ from 2026 we are going to upload.